the path. Okay, we generalize the path by adding some parameters. Okay, if we add parameters like eta, okay, natagi-add yung parameters eta. Hello, madungog ko ninyo? Hello? Hello?
Go, bro, sir.
Okay, okay.
Sir.
Okay, murag saba mo kay diri na ako sa pikas nga office. Anyway, so diri ta nag undang atong last time ba. Uh, we will um generalize our path. So natay parametric equation equal to this nga giada nako with some eta is one the eta as a function of time and with some parameter alpha. Okay. So let's see if makuha paghapon ka o unsay makuha nato sa ato ang g okay, sa ato ang integral of L dt. Okay? So, yeah, dito mag-start. And this eta at endpoints, okay? Take note your eta at endpoints. Oops. Endpoints meaning sa endpoints kay katong at T1 and T2, no? T1 is my initial time and T2 is my final time. So meaning sa kanang time naa siya sa iyahang fix nga initial o final point. So in this point we will note that the eta at the initial point say T1 and the final point T2 will vanish. Okay? So na siya condition na at T1 and T2 at initial times and at initial time and final time, the eta, the function eta is equal to 0. Okay? So, therefore, the integral j now becomes this. The integral j becomes this, which is now a function of alpha, which is equal to the integral of L dt. Okay? L, which is a function of y, and take note your y is not just a function of time but a function of alpha and time. Also a function of its velocity, which is also a function of alpha and time. And then nakoy time t there. Okay? So the L, the Lagrangian, is not just a function of time but a function of alpha and a parameter alpha and time t. Okay? So it is a function because nato nag-generalize na to ang y not in terms of time only but in terms of some parameters alpha. Okay? Some parameters alpha. Notice the eta function will vanish of 0 at initial and final point. Okay? So this is the general equation for our Hamilton's variational principle. Okay? So this lang ta nato kung sa ato makuha nga result in general form. Okay? So again, your L is a function of displacement, velocity, and this velocity and displacement is a function of alpha and time. Okay? Now, in the case of free fall, kabalo man ta sa free fall, no? The case of free fall, the velocity there, okay, the y dot, okay, is equal to some initial velocity, okay, plus the parameter alpha, eta dot times eta dot with respect to time, okay? Ngano galing ni? Kabalo man tani no kay nantaw na to sa pinakaunang equation, your displacement is a function of alpha and and time, and it is equal to this expression here, okay? So taking the derivative of that, you will get the velocity. So in free fall, na ako expression nga nga form sa ako ang velocity, okay? So we have that. And in this case, if we compare this in free fall, natay makuha ano no in dropping an object, nakoy makuha nga ingani nga form no 1/2 gt squared. If you remember, the displacement the displacement y is equal to minus 1/2. This is for dropping an object, okay? Dropping an an object in free fall, in which in this case your initial velocity is equal to 0. Why is that? And then the velocity y dot is just equal to negative gt. If you derive that with respect to time, makuha nimo is minus gt. So in this case, I will let specifically the y initial position, okay, at alpha 0, y when alpha is 0 and time at some time t, and also the y dot at some alpha equal to 0 times or a function of it's only a function of time, not a function of alpha. Okay? So, again, in free fall, fix ang ako ang y 0t. Meaning sa 0t is your alpha is equal to 0 there. So, fix ako ang y, 0t is a function of t only, and fix po ako ang y dot, which is equal to 0, which is equal to minus g times t. So, therefore, the Lagrangian becomes this. So, ang Lagrangian is just kinetic energy and potential energy minus potential energy. So, this is equal to 1 half m y dot square. Tama? 1 half mv square minus mg times y. So, in this case, the Lagrangian is just equal to this. 1 half m. Kung sakit akong y gani, y dot na ko is this. My y dot is that. The general expression of my y dot is that. So, we have y 0t plus alpha times eta, any function of time, eta square. This is my y dot, no? This is my y. Kulang pa kong dot dira, no? Alpha is some parameters which is basically a constant. So, it's not a function of time. Si alpha is a parameter which is not a function of time. So, kung derive mo y, ang imo lang mo derive is only the eta. Okay? So, ma-derive lang mo sa respect to time ng eta. Minus mg, my y is take notice na ako y as a function of time plus some alpha eta as a function of time. Okay, so this is my y, general expression of my y. Okay, so that's my Lagrangian. If you use the initial conditions like this, okay, kana, where your y 0t is minus 1 half gt square and then y dot 0t is minus gt. So ako na ibutan dira, no? Na ko'y 1 half. This is for free fall, okay? The case of free fall. The y dot is equal to minus gt, okay? Minus gt plus some constant, some function alpha, eta dot t quantity square minus mg. Take note, my y 0t is equal to minus 1 half gt square plus alpha eta as a function of time. Okay? So, unsa lang akong gibuhat, gi-change lang nako in case of free fall, I denote the y 0t and y dot 0t as minus 1 half gt square and minus gt respectively. Okay? And then, if we expand this one, this is a square, this is a binomial, okay, square of a binomial. So, if I expand the first term, I will get the Lagrangian is equal to this. Na ako'y minus g square t square. Sakto ba? Expand ako na, no? Minus g square t square minus 2 g t alpha n dot. Okay? N dot. Take note, n not n but eta. Okay, this is eta. Eta plus alpha square eta dot square. Okay, sakto ba? Plus alpha square eta dot square. So, take note, eta is a function of time. So, ano ako gisulat ang kaning comma t, no? Kaning close parenthesis, close open parenthesis t, because I know that eta is a function of time. Okay? Minus m g, isulod na ako ng mg, no? May mo siyang minus minus becomes plus. So, na ko mg square t square over 2. Sakto? Distribute na ko ang mg. So, na ko mg square t square over 2 minus mg alpha times eta. Okay? So, mg alpha times eta. Now, as you can see here, ay mag-cancel out. Okay, mag-cancel out ani. Yeah, na ano, kaning kulantaon nimo, may mag-cancel out nga if I distribute it again, kaning 1 half m, Ang tanong ko na yung magkansilat, no? Nako 1 half m g squared t squared minus, nako 2, no? 1 half m times 2 gt, that becomes gt alpha n dot m. Sakto na? Yeah, sakto na siguro na. Wala mo kansilat. Anyways, so nako 1 half mg square t square minus mgt alpha eta dot plus 1 half m alpha square eta dot square plus mg square t square over 2 minus mg alpha eta. Okay? And then, na ay okay, so mag-cancel out. But, na ay mag-add. Sakto ba? Na ay mag-add. Kaning nga term. O kaning nga term. Ba? So, na ako 1 half mg square t square plus 1 half mg square t square, that's equal to mg square t square lang. So, that the Lagrangian becomes, our Lagrangian becomes, i-add ako itong duha, no? So, may mo sa 1 half lang, plus 1 half, that's equal to 1. So, na ako mg square t square minus mgt alpha eta dot plus m alpha square eta dot square, which is that square over 2 minus mg alpha times eta. Okay? Times eta. Okay. So, ano ko gibuhat lang ako, combine lang ako ang duha ka term, no? Kaning mg square t square over 2. Okay? M Tura, no? Ako eta, yeah, sakto na na. Okay. And the next thing is I will factor out the m. Factor out na ko ang m. So, doon naman siya common factor ng m. If I factor out the m, so ang mabilin sa sulod is we have g square t square minus gt alpha eta dot plus alpha square eta dot square over 2 minus g alpha times eta. Okay? And then, I will factor out the alpha g. Alpha g, murag paro g, no? Alpha g ang may alpha g. Kanino? I will factor out the alpha g. Okay? Factor out ako ng alpha g sa sulod. So, your Lagrangian is just equal to this. Ako'y g square, t square. Then, I will factor out the minus alpha g. So, unsay mong bilin? Ako'y t eta dot. Okay? Plus na siya, no? Kay minus g alpha n. Eta, sorry. So, nako'y plus eta. Okay? Plus alpha square, eta square dot over 2. Okay? So akong gibuhat is nag-factor out lang og alpha g. Okay? Minus alpha g there. Minus alpha g. Okay. So, yeah. So, this will be your, this will be your L. Okay? This will be your L. And then, if I substitute this one to our J, then J becomes this. Then J becomes, so ako rin siyang integrate, no? Si J now, which is a function of alpha, is equal to the integral of L dt, no? L dt. So my L is given by this. So ako m g square t square minus alpha g t eta dot plus eta plus 1 half of alpha square eta dot square, then ako'y t. Okay? Minus mg t square minus alpha g tn plus 1 half. Yeah, so this will be my j. It's a function of alpha. Okay? Anong function lang mo siya sa alpha? Because you integrate the dt, no? You integrate the dt there, here. You integrate the dt with respect na siya sa fixed na value at t1 and t2, no? So, ang mabili na lang is in terms of alpha na lang, ang g. Okay. Notice the second term of the integral. So, lantaw na to ang second term of the integral kaning alpha g na to, no? The second term about the integral, the second term of the integral of the integral, which is katong alpha g na to, okay? Then this one, no? The negative alpha g, of course, this is integral of paano? Kaning dito. Alpha g are constant. So, pwede na ko sa pag sa integral. So, nakoy alpha g. Ang nabilin is katong t eta dot plus eta. Okay? D times t, no? So, muna kong second term, no? Sakto. This one. My second term, integral of this function dt. And alpha and g are constant. So, you can factor it out sa atong integral. So, this is just a a an integral two terms ng integral. So you can actually factor this out as minus alpha g integral of t eta dot t plus integral of eta from t1 to t2. Okay? So yeah, so kung ano t a eta dot dt and dt. Okay? If I use integration by parts, okay? If I use integration by parts, sa ako ang first term, okay? Kani bitaw, okay? Using integration by parts, siya, integration by parts. If I let u as t and du is equal to dt, and then I let v as ang nabili, no? Eta dot dt, and as you can see here, this is just equal to eta, right? Your v is equal to eta. Sakto? Okay, your eta dot is just derivative of eta with respect to dt. So, somewhat, they will cancel out. Di po siya mo cancel out. Kani bitaw? Kaning eta dot dt is just equal to eta dt. So, somewhat, this is just equal to integral of d eta. And integral of integral of d eta is just equal to eta. So that's why your v is equal to eta. Okay. So yeah. So we have the integration by parts, letting u as t, and then v is integral of eta dot dt. So your v is just equal to eta. So therefore, as you can see, this is uv minus v du, no? So the this one, the t eta dot dt becomes uv, that's t eta integrated from t1 to t2 minus v du. Akong v kay eta. Tapos ang du na ako is just d. Okay? So, the second term becomes this. So, the second term becomes this na ako'y ayan na, no? Oops. So, the second term becomes minus alpha g na ako'y t eta integrated from t1 to t2 minus eta dt integrated from t1 to t2. Muna akong first term. Akong second term is this eta eta dt from t1 to t2. Mag-cancel out siya, no? So, dunay mag-cancel out this one and the second term. So therefore, my second term, the second term of my integral is just equal to this, minus alpha g eta integrated from napakoy t, no? Napakoy t, then eta integrated from t1 and t2. Okay? But if you substitute t2 and t1 here, nakoy nga no? Minus alpha g T2 eta as a function of T2 minus plus no plus alpha G T1 eta as a function of T1. But we have this condition, no? We have this condition nga akong gisulat kayo na. Yan eh. The endpoints, the eta as a function of T1 and the eta as a function of T2 will vanish. Okay? So, na ko assumption nga na, the eta as a function of T1 and the eta as a function of T2 will vanish. So, therefore, this becomes 0 and this one is also equal to 0. So, the second integral is just equal to 0. Okay? So, yung harap sa kasayo. Ang second integral, if you do the integral of the second term, that would be equal to 0 since, take note, since the eta as a function of T1 at the endpoints is just equal to eta as a function of T2 which is equal to 0. So, walay problema sa second term sa ako ang J. So, sa may tabo sa akong J, duha na lang ka term. Kaya mag-vanish man akong second term, so the J as a function of alpha becomes, it will be reduced into this. Na ako T1, T2, M. So, ito nabilin gani, G square, T square, no? G square, T square plus 1 half alpha square eta dot square. Okay? The dt. Okay? That's my J now. And the first term is just usual integration. Okay? The first term, integrate lang nimo na ako'y M G square integral of T square dt from T1 to T2, tama ba? Plus 1 half alpha square integral of eta square dt from T1 to T2. Okay? Tama ba? Sakto na? The second term will vanish. Yung second term sa akong J kay na kay mawala to siya. So, ma-reduce into two terms na lang. The first term which is this mg square T square dt, and then the new second term is just 1 half alpha square na walang m. Asang m? Napay m dire na, dire na po m. Okay? I-distribute mo na ako ang m sa duha ka integral. So 1 half m alpha square integral of eta dot square d. Okay? So kabalo ko sa integral sa second term. Sakto? Kabalo ko sa integral sa second term. Not the second term, but the first term. So, my J alpha, integral of T square is just T cube over 3, no? So, nakoy mg square T cube over 3 integrated from T1 to T2. Copy lang nako ang second term. 1 half m alpha square eta dot square T from T1 to T2. Okay? So, I have mg square over 3. This one is T2 minus T1. And then I have 1 half m alpha square. I cannot integrate this eta square dt diretso, no? Hindi na ako sa ma-integrate. Tama? So, kaya lang sana ako nagyan. Okay? So, this is my J alpha na. So, your second integral, it depends on the value of your eta. Okay? It will depend on the value of your eta. But as you can see here, in terms of alpha, kung taon mo, first term is not a function of alpha. Sakto? First term is just mg square over 3 t2 minus t1. So, somewhat, it is just a constant. Okay? It is just a constant. But my second term is a function of alpha, square. It means that if you graph this j here, ang may tabo, if you graph this one, the graph will be a parabola. In terms of alpha, take note, your j is a function of alpha man, no? Your j is a function of alpha. So, as you can see, this is a quadratic equation in terms of alpha. Tama? Kay alpha square man nasa. The exponent of your alpha is square. Kaning integral of eta dot square is just if nakay specific na value sa imong eta, which is a function of time. Okay? Then do the derivatives, take the square, integrate with respect to dt. Somewhat makuha nimo ani is some constant lang gyapon. So as you can see, your j is, if you graph your j in terms of alpha, this is the equation will be a quadratic equation. Okay? So you can write this as, if you let the first term as constant a plus the integral as b alpha square. Okay, if you let the a is equal to mg square over 3 t2 minus t1, b is 1 half m integral of eta dot square dt, then this is just a quadratic equation with respect to our alpha, with our alpha. Okay, so this is actually a quadratic equation. Take note ha, depende sa imong value sa n, pero if you graph this with respect to alpha, makuha nimo is a parabola. Okay? So makuha nimo, if you graph that, it is a parabola. Depende na lang din kung saan value sa imong a at sa imong b. Okay? So take note here, a here, where a is katong mg over 3 t2 minus t1. This is in the case of free fall, no? Kung lahi nga problem, lahi nga system, then lahi po din mong constant nga A, lahi po din mong constant nga B. So B is equal to 1 half M, sa to? 1 half M integral of eta dot square. Integral of eta dot square dt. Okay? So again, kani, dali raman nga integral. Depende kung sa value sa imong eta, no? Depende sa imong value sa eta. So A is that, B is this sum constant with respect to alpha. So your J is just equal to is a quadratic equation with respect to alpha. Now, uh, the value of the integral of the integral, okay, the value of the integral is minimum. Okay, it is minimum. Is a minimum when you derive the j. Okay, derive the j with respect to alpha, where alpha is equal to 0 and this is equal to. Tama ba? Muna itong ulang taon mo, muna ito ang actually i-discuss last time. To take the minimum value of the function, just take the derivative, set it to 0, solve for the unknown one, and you will get the minimum point or minimum value of this function. Okay? So, in this case, it occurs, okay, only at alpha equal to 0. Okay? Kani siya is, it is true always for any integral of j of a function of y. Okay? So, kung sa ito itong gibuhat, kung balik ko na ito sa pinakauna, kanina na magidunta ang ato ang no? Y na magidunta ang ato ang y as a function of time na mo itong position or displacement. No? But, na-prove na to na when you generalize the displacement y, which has some function, idungagan na kong function alpha eta, na-prove na to nga your j is also a minimum, it has a minimum value when your alpha is just equal to 0. Okay? So when your alpha is just equal to 0. Okay? It occurs only at alpha equal to 0. Kung kuha na to ang minimum value ani nga j, dapat your alpha is equal to 0. Okay? So it is true, take note always for any integral j of a function, of the function y. Okay? The alpha is equal. Okay, say for example, so take note ha, your j is given by this, si eta, depende sa imong value sa eta na dayon, ni mo makuha ang imong exact function sa imong or sa ato ang j. Okay? For example, we have uh, oops, a sinusoidal function. For example, na ko sinusoidal nga function. Okay, uh, six, ano, 7, 8, chapter 10. And this one, no? For example, I have example 10.1.6. Sample from point 1. Okay. Oops. So assume that a particle travel along sinusoidal path, okay? Say from x equals 0 to x to some x1. Okay? So now for particles traveling along a sinusoidal path. Sinusoidal path means there is a period, it is a function of a sine or a cosine. Okay, ang mga y is a function of either a cosine or a sine. Okay? Manang itawag niya nga sinusoidal path from a point from x equals 0 to x equals some x1. Okay, during a time interval delta t. So delta t is just t2 minus t1. Okay, in a force field free region of space. If I use Hamilton's principle, uh, showing that the amplitude of the assumed sinusoidal path is zero. Okay, using again Hamilton's principle to show that the amplitude of the assumed sinusoidal path is zero, implying that the path that particle takes is really a straight line between the 2 points and it's not a sinusoidal or yeah, it's not a sinusoidal path. Okay? Kaya sa ito, ako nga no, ka-assume ka nga ang imong y, your displacement y is a sinusoidal function. Okay? So a sinusoidal function. Okay, so somewhat ang iyahang path is kani siya. Uh, from 0 to x1 napagpas nga and so on. Pero if I use Hamilton's principle na show niya that a is equal to 0, the amplitude is 0, meaning the original path or the true path taken by this particle from 0 to x1 is just this straight line here. Okay, again using um, variational Hamilton's variational principle. Okay, so solution we have this. Take note, we have path solution. We have this delta t is equal to t2 minus t1, no? And then you can also write delta t in terms of take note velocity is just equal to distance over time. So you can write delta t as the total distance traveled over the velocity of the particle. I call that one as vx. Okay, I call that one as, so this is the total distance. Okay, and then this is the velocity vx. Okay, velocity vx. Okay, so from here we have this path. Our path is just x equal to um, the velocity times time. Okay, so we have these useful equations from kinematic equations. There is our x, our displacement x is equal to this, and our y, displacement y, is a sinusoidal function. Say plus and minus eta sine of omega t. Okay, omega here is angular frequency, in which we can write this as pi vx t over x1. Anong ingani yung forma niya? Dako ang omega t. Anong ingani yung forma, no? Ano pa to, no? Nakoy. Anong pi vx t over x1 ang ako ang sulod sa ako ang sinusoidal function. Eta here is the amplitude. Okay, eta is the amplitude here. But kabalo tali, no? Eta is the amplitude in our y nga displacement. But we don't know why is it that the omega is equal to pi vx over x1. Asam ni sa gikan di? Ako'y okay. If I draw the path again. So na ako yung nga path, no? Ang path na ko is this 0 to x1. Okay? To x1. Okay? But this is just half of the wavelength. Sakto? As you can see, ang path niya from 0 to x1 is just half of the wavelength. So meaning this is just period over 2, no? Ang iyahang if you continue graphing the displacement, it looks like this. Okay, so yung ano sa forma dapat, no? So as you can see, the period, okay, of the sinusoidal function, the period is just this one, no? Kani akong period dari, no? And if this is x1, then this is equal to 2x1. Sakto? Kaya equal lang man ang length dapat sa iyahang half lang man imo nako ang wavelength ani, no? So nakoy nga na, and using the concept of period, I can show that the Vx is just equal to the distance, total distance over the period t, no? The total distance now is equal to 2x1 because sa kaning nga period, pwede ra gyapon ka mogamit og x1 over 1 half of t. Same lang magyapon na siya, no? You can write the Vx as the distance x1 over, take note, moabot ka sa x1, moabot ka sa x1 at period equal to t over 2, no? At period equal to t over 2. Same lang yapon sa answer, 2x1 over t. Okay? So that's my Vx, and my omega is just equal to 2 pi f. Okay? Take note, um, ang ato ang goal is, ang nasa sulod ani is just sine of omega t, no? And idiretso niya nga omega is equal to pi Vx over x1. So we will prove that omega is equal to this one, pi Vx over x1. So we have omega is just equal to 2 pi f, or if you write this in terms of period, this is equal to 2 pi over period. Sakto? 2 pi over period. And we know that Vx is equal to 2x1 over the period. So therefore, period here is equal to 2x1 over the Vx. So therefore, omega is equal to 2 pi over the period, which is equal to 2x1 over Vx. Mag-cancel out ng 2. Cancel out the 2. Bring up the Vx in the numerator, you will get pi Vx over x1. So that's why my angular frequency is equal to pi Vx over x1. Okay? So that's why kung sinusoidal function y is equal to some amplitude eta times sine of omega, which is pi Vx over x1 times our time t. Okay, so we know now the displacement y. We also know now we also know the function x. Okay, the function x. Now, if I put that one into our Lagrangian, so unsa akong Lagrangian diari? Okay, take note, your particle has two kinetic energy. Tama? Your particle, if you look on the figure, si particle kay naa siya motion along x and motion along y. So therefore, your kinetic energy has two terms. Na ako'y kinetic energy along x and kinetic energy along y. So therefore, the Lagrangian is just equal to this. L is equal to 1 half m times x dot square plus y dot square. Sakto? I have two kinetic energies. Kinetic energy along x and kinetic energy along y. In 3 dimension, mudungag ka og term for the z dot square. Okay? For the motion along z. So that's my kinetic energy minus some potential v. So ako lang generalize ang potential to that v. Okay? Okay, so if I put the x dot and y dot, okay? So, unsa ito akong x gani? Akong x is this, okay? My x is that. So, if my x is equal to vxt, then therefore, my x dot is just equal to vx. Sakto ba? Tama, no? If I derive my x with respect to time, ang makuha lang na ko is only vx. Okay, tama? How about my y? My y is equal to plus minus eta of sine. So ito, pi vx over x1 times t. So if I derive this one, with respect to time, nakoy derivative of sine is cosine. So nakoy plus minus gyapon, no? Dili mag-change ang sine. Cosine of pi vx over x1 times t times the derivative of the function inside the sinusoidal function. This is pi vx over x x1. Sakto? So this is my y dot. This is my y dot by mm, Vx over x. Okay. If I put that one there, in our Lagrangian becomes 1 half m. So ito akong x dot is just Vx. So nako Vx square plus my y is just this. Ako lang ibutang sa ako plus n by Vx over x1 cosine of 5Vx over x1 times t. Okay? And this is a square, no? Y that square. So na ko ay eta. Plus minus square ni mo kay plus minus lang gihap. Di plus ra tanan, no? Kining plus minus dari. Plus minus if you take the square of that, ang resulting value niya is just plus square lang. Plus eta square. Okay? So na ko plus eta pi Vx over x1 quantity square cosine square of 5Vx over x1 times t. So this is my y dot minus some potential v. Okay? So muna akong y dot square. Sorry, take note. N pi Vx over x1 square cosine of 5Vx over x1 t then minus v. V here is constant because the motion is in the force field free region. Okay? Gi-specify po sa to ang example nga ang particle na to is in a force field free region of space. Meaning, mura ra siya og free particle. Subject to zero potential. Okay? So, the V here is some constant. Okay? Any constant lang. It's not a function of Y. It's not a function of X. But some potential, some constant function V. Okay? So, note, V is constant. Not the Vx, but the potential. Okay? V is constant since your particle is subject to a force field free region. Okay? Because the motion is is in force field free region. Pwede siya ma-zero, pwede po siya i-generalize into some constant value. Okay? Free region. Okay? Now, that's my L. Okay? That's my L. If you put that one to our J. Okay? So, muna akong L ani nga example. Muna akong Lagrangian sa akong example. Then, my J, the J becomes, so, akong J kay LDT raman, no? LDT. So, na ko J equal to integral of that from 0 to time t. Okay? I let initial time into 0 and then some final time, say, t. Okay? So, na ako 1 half m up to 1 half m of Vx square plus kanino? Plus nga eta square, eta pi Vx dx over x1 square cosine square of pi Vx over x1 times t minus potential V, which is some constant. Okay, which is just a constant. You can factor it out sa ato sa imong integral. Okay. What is my t here? And pi where t, we know t is just equal to t nga nasa integral sa akong upper bound sa akong integral is just equal to x1 over Vx. Sakto ba? Tama ba ni? Nasulat na ito nila sa itong pinakauna, no? Okay, ito. Yeah, this one, no? the delta t. Okay, the delta t is just total distance over the velocity dx. Okay, so delta t is just t minus 0, so therefore my t is just x1 over vx. Okay, so my t is just x1 over vx. So to the integral, you will get this. Nakoy pila ka book term, tulo. Okay, nakoy tulo ka term sa akong j, no? Nakoy first term is we have 1 half m dx squared integral of dt from 0 to x1 over vx. Okay? Vx is just constant here. Okay? So, gipagawas na ko siya. Pwede na ko siya ipagawas sa ang integral. Okay? And then, second term is we have plus 1 half m. Kani, constant naman no? Eta pi dx over x1 quantity square integral of cosine square pi vx x1t dt. Okay? From 0 to x1 over vx. Sakto ba? Sakto no? 1 half m. Yeah, sakto na, no? Sakto na sa cosine dt minus v. Okay? Integral of 0 to x1 over vx dt. Okay, so there's no problem with our first term and our second term. Okay, wala tayong problema sa first term o ang second term. Ang problema nato is ang third term, sorry. Wala problema sa first o sa second, sa third term. Our problem is the second term. Okay? So if I do the integral for first term, it's just integral of dt is just t. And then it runs from 0 to x1 over vx. So ang may tabo, may more sa nga nila, no? Ako 1 half m dx squared times x1 over vx. Sakto? x1 over vx lang because the integral of this is just t. And then where t runs from 0 to x1 over vx. Okay? And the third term is just p, minus, no? Minus. Yeah, this is minus. So na ako yung minus v times x1 over vx na po. Sakto? Kung third term is just same lang siya sa kaning first term, no? So na ako x1 over vx times the potential v. Take note, kaning v there is our potential while vx is the velocity. But my second term is equal to this. My second term is equal to plus m dx eta square pi square over 4x x1 x1. Okay? So my second term, if you do the integral, if you do the integral of cosine square minus b x1, if I do the integral of cosine square from 0 to x1 over vx, I will get this answer, mvx eta square pi square over 4x1. And I will not do this one, you will do this, you will do the integral. This will be your assignment. Okay? Assignment. Kung ano butang daan ron, para limot ko, no? 1 half m eta pi vx over x1 square integral of cosine square of pi vx over x1 times t from 0 to x1 over vx dt. Show that this one is equal to m vx eta square pi square over 4x1. Okay, again, this will be your assignment. Okay? Okay? This will be your assignment. Kung i-post daan na, direto taman siguro, no? We will continue this one next meeting. Hapit na kung man. But your assignment will be this paint. Post na ko daan na. Oops. Oops. So we'll continue this one next meeting. But nakuha na to ang J, no? Nakuha na to ang J equal to that one. Oops. Save. Isa lang assignment. Save. Oops. Oops. 52. Assignment. Pila na ning assignment. Tapos. So yeah, that's it. That's it for today. Any question? Again, we'll continue this one next karong Wednesday. Your assignment will be this assignment. Attendance sa DETSA, no? Dito lang ha. Sa Mugawa ha, mag-attendance sa DETSA. Do you have any questions?
None, sir.
Okay. So, yeah, let's continue this one next meeting. 52, segment 3.